Hi, and welcome to our Fall 2023 Demo Day for Techstars Space, airing on Kernel. I'm Matt Kozlov, Managing Director of the program, and on behalf of Techstars and the 11 outstanding companies presenting today, thank you for joining us. For those of you new to Techstars, we are the global network that helps entrepreneurs succeed. To date, we've invested in over 3,800 companies, and our portfolio's combined market cap is over $105 billion. We are proud to be one of the most active aerospace and defense investors in the United States, having invested in over 135 defense companies who have collectively raised over $1.7 billion. Earlier this morning, we aired our demo day on Kernel for Techstars LA, powered by JP Morgan. If you were unable to join us, we encourage you to go back and watch those pitches. Several of the companies in the LA program are also in the aerospace and defense sector. You can find a link to those pitches in the About section on this page. Today, you'll hear from the companies graduating from this fall's Techstars Space program in partnership with NASA's Jet Propulsion Lab and the United States Space Force. Looking forward to this coming spring, in March we will be running another Techstars LA program powered by JP Morgan, as well as our Techstars Healthcare Accelerator in partnership with Cedars-Sinai, Point32 Health, UC Irvine Health, and United Healthcare. And next fall, we will once again run Techstars LA and Techstars Space. You're about to hear 11 pitches from 11 outstanding founders, as well as remarks from our partners at JPL and the Space Force. You'll also hear from our esteemed guest, Dan Golden, NASA's longest-serving administrator and one of this program's most valuable mentors. Thanks to Kernel, this is an interactive event. You'll see live chat to the side, as well as overviews on every company, if they're raising, and one-click buttons to get in touch. Please reach out to them right here on the Kernel platform if you'd like to learn more, but also reach out to them if you think you can be helpful. Our ask of you today is that you try to find at least one company that you can be helpful to. Maybe it's an introduction to a customer, a potential hire, an investor. If all of you watching today do one thing, just one thing, imagine what these teams will accomplish just today. And now, please meet the 2023 fall class of Techstars Space.
Hi, I'm Haley, CEO and founder of Locus Luck. Have you ever had the frustration of Google Maps blue dot being incredibly inaccurate while you're driving? Well, fortunately, humans can rely on our own senses to figure out where we actually are. Unfortunately, automated ground vehicles aren't as lucky. News surfaces daily of these autonomous cars failing because the vehicle's algorithms treat that faulty blue dot as a source of absolute truth, resulting in high-risk accidents, billions in equipment loss, and tragically, even loss of life. Just a few meters of error can mean the difference between safe operation and crashing, mission success and failure, and life and death. This is even more alarming in industries where the outcomes are overwhelmingly more catastrophic and expensive, such as commercial aviation, unmanned aerial vehicle operation, space-based navigation, advanced military operations, and precision outdoor robotics. This escalating issue of unreliable positioning threatens global safety. Locus Luck is disrupting a $200 billion market by delivering a high-performance GPS platform that allows for centimeter-level positioning while maintaining high reliability even in challenging conditions like urban areas or places with GPS interference, all at a price that can scale into mass market deployment. Unlike existing GPS solutions, which are unconfigurable hardware devices, our GPS platform is deployed on-premise in software, enabling our customers to modify internal configurations to achieve centimeter-accurate performance in any vehicle, anywhere, unlocking new opportunities and possibilities for GPS positioning. We sell our plug-and-play GPS solution directly to commercial and defense customers to support their advanced technologies that demand more secure and precise positioning. We are leveraging a decade's worth of cutting-edge research and development at UT Austin, and today, our mature product is at a NASA technology readiness level of 7, with spaceflight heritage across a large commercial constellation of LEO satellites. We were recently selected for a SOCOM grant to deliver resilient positioning to enhance and strengthen the Special Forces ground vehicle capabilities. And I am also thrilled to announce that we're in a multi-million-dollar contract negotiation with an aerospace company that allows us to scale our team and operate profitably. I am a trained aerospace engineer from MIT and UT Austin, and working in industry at Boeing, Aurora Flight Sciences, Kitty Hawk, and Lockheed Martin, where I've tackled some of the most complex issues in sensor technology for advanced autonomous aircraft. Our team consists of robust engineers, savvy business leaders, and experienced advisors, all working together to meet the urgent demand for improved positioning solutions. Locus Luck strives to ensure safe autonomous mobility on the ground, in the skies, and in space. Partner with us to unlock the future of autonomy with our cutting-edge positioning technology.
Hi everyone, I'm Chris Newton, co-founder and CEO of Axion On Space. For nearly 2 decades, I've been working in the launch industry, turning its toughest challenges into landmark achievements. From slosh and anti-vortex for SpaceX's Falcon 1 and Falcon 9, to launch operations and build of the first autonomous drone ship, to testing of the world's largest composite cryotank, and leading a team of over 150 at Relativity and launching the world's first 3D printed rocket. I am also joined by my co-founder and COO, Jonathan Lunn, who has over a decade and a half of experience solving challenging engineering problems, from hydroelectric dams to skyscrapers and rocket factories to orbital launch complexes. Throughout these endeavors, we have found some recurring challenges across launch. Rockets are overly complex and not operationally friendly. They demand massive teams of engineers and technicians to perform what should be relatively simple and routine tasks and take weeks to months to prepare for launch. From integrating the stages once they arrive at the launch site, to mating the rocket, to rolling out and going vertical. When a problem emerges, even a routine task like replacing an engine seal after a static fire means dismantling large sections of the rocket, leading to weeks of downtime. This is like taking apart your entire car just to change the oil filter. Yet this is the current state of affairs in the rocket industry. Extensive delays, limited launch frequency from a single pad, and a scarcity of options in the medium to heavy launch market. It is not uncommon for wait times to exceed 2 years for a customer to fly. At Axion, we look to make a step change in the launch industry. Our approach starts with the end users in mind. Those who work on and launch the rocket, streamlining intricate operations and substantially cutting down on the workforce traditionally needed. Our vision? A fully reusable rocket capable of 25 metric tons to low Earth orbit and providing on-demand launch in as little as 24 hours from a single site. Our innovation lies in our modular plug-and-play design. Hardware that connects effortlessly like Lego blocks, combined with the capability for rapid assembly exchange similar to that of a Formula One pit stop. This paves the way for simplified operations and leaner teams, setting a new benchmark for launch capabilities in the industry. Imagine a routine engine replacement that typically takes 72 hours for a team of 20, now less than an hour for just 2 technicians. For booster refurbishment, going from a team of 50 in 5 months, reduced to a team of 10 and ready to fly again in less than a week. And streamlining launch control from 50 engineers on console down to just 2. Pilot and co-pilot. Axion increases launch cadence per site by 15 times compared to the current industry leader. We offer customers a 50x reduction in launch wait times and provide a more flexible and cost-effective alternative. This positions us to competitively serve the growing launch services market, projected to grow by more than 3.5 times over the next decade, exceeding $50 billion by 2032. We have made significant strides on our detailed modeling and analysis of our vehicle and are ready to step into build and test of our development hardware. Join us as we reshape the future of spaceflight.
Hi, I'm Alessandro, founder and CEO of Magma Space. Imagine aiming a laser pointer at a baseball-sized target 10 feet away. Easy, right? Now, imagine hitting the target across a baseball field. Definitely more challenging. For a satellite, your target is 10,000 times as far. Satellites are not perfectly stable. Small vibrations make the satellite wobble, meaning, like us, they don't always hit the target. This is critical for satellite communication, which will experience massive data growth over the next decade, surpassing 300 billion gigabytes by 2033. High-speed laser communication is the only solution, but pointing uncertainty is constraining data rates to just a fraction of their potential. And satellite vibrations are an absolute killer to high-resolution satellite imaging, carrying sharpness and concealing critical details needed for national security, urban planning, gas leak detection, and more. At Magma Space, we are addressing the root cause of vibrations by eliminating their main source: ball bearings within spinning wheels that maneuver every spacecraft. These wheels are so vital to satellite positioning that they cost hundreds of thousands, if not millions, per satellite. Our solution is a novel magnetic bearing, which levitate the wheels, resulting in virtually no vibrations and a drastic increase in reliability. Our prototypes tested at NASA reduced vibrations by an incredible 95%, achieving a level of stability not seen before. This will enable next-generation satellites with 10 times better performance. And if that's not enough, our magnetic wheel can dual function as a control system and power system. That means one system that both maneuver the satellites and provide 10 times the power of traditional satellites, overcoming one of the main limitations of today's satellites. Our first focus is in the Earth observation and laser communication industries, a $4 billion market. But our ability to include power storage doubles the market potential by 2028. And we have the right team to execute this. Since starting my PhD a decade ago, I've experienced firsthand the difficulty in mitigating satellite vibrations, and eventually realized that removing the source of vibrations was going to be a game changer. That is why I founded Magma. And while I focus on tech development, Jordan brings business and operational experience with an MBA from MIT, a background at Boeing and Amazon. To date, we have received over $1 million in grants from NASA and the NSF, and letters of intent from government and commercial organizations. The space industry is at an inflection point. With 20,000 satellites launching over the next decade, our technology is the key to unlocking unmatched capabilities in satellite imaging and communication. So join us in shaping a new era of spacecraft hardware for the next giant leap in satellite performance.
Hi, I'm Shoaib, CEO of Satellite Imagery. We're building satellites that capture data-rich images with far more information than the standard satellites you know. Mining for new minerals like lithium and cobalt to transition from a fossil fuel-based industry to electrification is challenging. Last year, Australian companies spent over $4 billion on mineral exploration. But even with such high costs, success isn't always guaranteed, and many companies go bankrupt. Surveying large areas of land involve either land-based or air-based surveys. But we offer a much more holistic solution. Similar to how an X-ray can see throughout the human body to look for broken bones, our satellite sensor technology can see throughout the Earth's atmosphere and mass to look for not only mineral deposits, but for oil and gas reserves and the emissions stemming from those as well. Transitioning to cleaner sources of energy cannot be done overnight, but we can make that transition a lot more smoother while making oil and gas ventures a lot more eco-friendly. We'll take a picture from space and you'll know where to dig. Hyperspectral imagery looks deeper into the spectrum of light to detect unseen chemical compositions. This gives us hundreds of data points to analyze compared to only a handful in industry-standard satellite imagery. From an image, we're able to break down the chemicals an object is made out of. Beyond mining, we're using this data for nutrition and yield in agriculture, as well as emissions in the atmosphere. And we're building these sensors in-house, with back-to-back launches coming up this December and in February, made possible by our speed and technical advantages. And we're committed to delivering results. We're further building an entire 18-satellite constellation to image the world on a daily basis. Our demonstration mission over the rainbow has already generated strong interest, with all the data capacity for 2024 being sold out. And we've done it all for just under $1 million. This allows us to make our imagery 10 times more affordable than products already out there on the market. We're serving this data through our user-friendly data platform, making the entire process from tasking to delivery super streamlined. We've collected over $95 million in letters of intent, from agtech companies to mining operations. And of that, $320,000 has already converted into binding revenue. We're also excited to announce that we're partnering with the UAE Space Agency and Bayanat to serve our imagery data through their national GIQ platform, helping us sell our imagery data into the Middle Eastern region. And behind all of that is us. I'm a 776 fellow, supported by Alexis Ohanian's foundation, helping us build climate solutions. with a background in building and launching payloads on high-powered rockets. My co-founder Joey is a mechanical engineer who has a research background in hyperspectral and photonic systems. And the rest of our team has built everything from Mars rovers to self-driving race cars. And we have the only PhD candidate in Australia pursuing hyperspectral imagery as a part of our team. At Esper, we're building the infrastructure to the solutions to the biggest challenges our planet faces. And we invite you to join us on our journey.
And now a few words from our partner, NASA's Jet Propulsion Lab.
Hi, I'm Tom Swig, Chief Technologist at NASA's Jet Propulsion Laboratory. Over my 3 decades at JPL, we have witnessed remarkable milestones, including Mars Pathfinder, Cassini-Huygens mission to Saturn, Spitzer's first direct detection of exoplanet light, and a range of Earth observations. At JPL, we like to say we are the first space startup. Our partnership with Techstars Space reflects our shared journey. We provide the founders with mentorship, strategic insights, introductions to our staff, and visits to our facility. Together, we are a team of innovators and dreamers, daring to push boundaries. As we applaud the achievements of these 11 dynamic startups, let's recognize their role in space exploration. They are a team of dreamers and innovators, pushing boundaries and charting new courses in space technology. Together, we are united in a mission to explore, discover, and embrace the challenge of daring mighty things together.
Hi, I'm Nehal Gajar, founder and CEO of IMMetalX. I'm an aerospace engineer turned entrepreneur with 3 successful companies under my belt. Over the course of my career, I've touched a wide spectrum of aerospace technologies, ranging from unmanned aerial vehicles to jet engines to new forms of renewable energy. And in my work in sustainability, I was led to understand increasing threats that exist in low Earth orbit, ranging from orbiting debris to undetected weaponized satellites. At any given moment in time, these 100 million objects and debris are traveling at 8 times the speed of a bullet. These objects are fast and destructive, in some cases, causing mission-ending damage to satellites and sensors. As the number of objects continues to grow in low Earth orbit, the likelihood of collisions increases. To give you an example, this 5-centimeter sized object that fits in your hand has the same kinetic energy as being hit by a bus. Yet today, less than 1% of destructive and undetectable objects are being tracked. That is the challenge IMMetalX is taking on. IMMetalX is developing the first of its kind, low-cost, agile constellation to detect, track, characterize, maintain custody of objects less than 10 centimeter. How do we do this? Through a combination of satellites and sensors. While most constellations point down at Earth, ours points away. This allows IMMetalX to be closer to the actual threats, thereby enabling higher fidelity imagery and measurements that are 2x more accurate and precise than traditional methods. We use advanced sensors, algorithms, and communications. Currently, 40,000 objects are cataloged. We plan to scale this by 10x. Our initial 5-year plan is to capture 200 million through data as a service, which includes early warnings, insights, and inspections for government and commercial clients, aiming for over 2 billion in revenue within 10 years. While other companies are just getting started, our team is actively refining the solution. We have won 9 awards, including 2 phase 2 contracts and commercial revenue, together totaling 3.95 million. Without any revenue share, we've obtained several patents, licensed technology from NASA, and a major research institution. And in the next year, we'll develop, test, and integrate our platform and launch 2 satellites. My co-founder and I have worked together for 8 years and known each other for more than 25. Our team comes from major space organizations like NASA, Raytheon, Velodyne, and JPL, and advisors who have been former leaders at AFRL Space Domain Awareness, JPL, and Naval Research Lab. We invite you to reach out and learn more about how IMMetalX is taking on this multi-billion-dollar market by addressing organic and man-made threats happening each day above our heads. Thank you.
Hi, I'm Bosco, the co-founder and CEO of Little Labs. In 1946, a camera attached to a rocket captured an image on film. The film was then sent back to ground in a metal box, free-falling from the sky. Once on ground, the film was processed into this amazing image, the first ever of our planet seen from space. Now, almost 80 years later, our capabilities have dramatically evolved, and we now capture gigabytes and terabytes of data from space every single day. But the basic three-step approach has not changed. Before we can use this data and process it into useful insights, we first need to send the data back to ground. There are two problems. One, downlinking this amount of data is expensive, costing satellite operators hundreds of millions of dollars a year. And two, downlinking is painfully slow. Users have to wait for hours and days to get their insights. That simply does not work in situations where every minute counts and where lives and billions of dollars are on the line. Think about wildfire detection, maritime surveillance over vast oceans, banks and insurance companies actively monitoring their investments and portfolio, and national security. Users have to know what's happening now, not hours or days ago, and this is why we built Little Labs. We provide space insights not in hours or days, but within minutes. We develop software product that can run and process data right on the satellite, removing the need to downlink everything. Here's one example. A satellite captured this image covering hundreds of miles of wild forest, and is gigabytes in size. Instead of spending hours to downlink this image, we process it right on board the satellite, detect a fire, generate these small and precise coordinates, and immediately deliver them to the responders through our platform. Now, because we only send back what's needed, we can reduce downlink by 98% and deliver insights within 7 minutes. Much more efficient, cheaper, and quicker. We're going after the $15 billion space data and insights market by licensing our software to satellite operators and providing subscription-based insights to the end users. Our product has run in space. In early 2023, we successfully demonstrated our solution on the Orbit satellite. We are working with Sidus Space, a US satellite operator, to monitor illegal fishing activities around the coast of Thailand and perform cloud detection in space. Since the beginning of Techstars, we have gathered 4 LOIs, including with Kepler Communication, Loft Orbital, and more. We have an SBR award with the US Air Force in rapid surveillance capabilities and have secured their support to apply for $3 million worth of upcoming contracting opportunities. I spent 13 years in a commodity trading bank and have first-hand experience on the lost opportunities when we don't have quick insights. During my time at the University of Oxford, I met my co-founder Gaurav, who has spent 15 years in software engineering and building products. We are supported by an amazing team of domain experts with a deep understanding of space and defense. So we're Little Labs, and we're unlocking the power of space insights by making them available within minutes. Join us on this mission. Thank you.
In 1968, semiconductor chips were a new industry, but already at $1 billion. Today, the industry is over $600 billion a year and provides a critical technology underpinning our economy and national security. This incredible 5-decade growth story is linked to the miniaturization of electronics that we commonly refer to as Moore's Law. I'm Chan Husko, founder and CEO of Iris Light Technologies. At Iris, we are performing the Moore's Law for photonic chips, or light chips. Light chips are a rapidly growing segment with $4 billion in annual revenue. Today, they are used in specialist applications inside cloud data centers to move around hundreds of gigabytes of data, documents, and videos. However, light can do so much more. Light chips hold the potential to revolutionize how we live our lives through new approaches to vision for autonomous systems, continuous health monitoring on personal devices, increased data transfer, and unlocking the power of quantum technology. The bottleneck to greater market adoption is a manufacturing issue we call the silicon laser problem. Today, there are separate supply chains, one for light chips and a second one for the lasers powering the chip. Let's take a closer look at how light chip products are made. The gold standard of electronics manufacturing is a silicon wafer containing hundreds of state-of-the-art chips. To make a light chip product today, a single bulky laser is glued onto the surface of a silicon light chip containing thousands of tiny sophisticated components. Today's lasers occupy valuable chip real estate and cost at least 20% of a typical product. What's worse, emerging markets needing chips with even more lasers to be useful. The unit economics simply do not scale for widespread market adoption. At Piersite, we've invented a new way of making lasers by combining our light-emitting ink with conventional silicon wafers. This enables us to crack the supply chain bottleneck by embedding lasers directly on the chip instead of gluing them on the surface. Our core business model consists of an intellectual property license fee for every wafer produced using our process. Piersite streamlines chip design by supplying ready-to-use wafers, enabling chip makers to sell more valuable chips, and freeing designers to focus on market growth without supply chain hassles to power the most essential devices in our daily lives. Our team invented the core technology, leveraging millions of dollars in R&D funding before spinning out and licensing 4 patents from Argonne National Lab and Northwestern University. Our advisors bring additional experience in deep tech product development and scaled manufacturing expertise. We've had incredible supporters and raised $2.2 million of funding today. This includes 6 contracts across multiple federal agencies with $3.3 million in potential follow-on opportunities. Beyond the funding, we formed partnerships with manufacturing leaders at IMMetalX and NextFlex, as well as signed R&D agreements with the Air Force and Argonne National Lab. On the commercial side, we've signed 9 LOIs with corporate entities ranging from aerospace, medical devices, and semiconductor manufacturing. We're proud to have achieved these milestones efficiently with less than $500,000 in pre-seed capital and are looking forward to our next phase of growth. At Piersite, our mission is to expand the impact of light chips and grow the industry from $4 billion to $400 billion. Come join us on our journey to power the Moore's Law for light chips and put the power of light in your hands.
And now a few words for our partner, the United States Space Force.
Hello, I'm Arthur Grijalva, Director of the United States Space Force. Over my time with the Space Force, I've led initiatives that focus on rapid response, innovation, and strategic partnerships, much like the ones nurtured with Techstars Space. Our collaboration with Techstars Space is more than a partnership. It's a strategic alliance that strengthens our nation's defense through innovation. The Space Force has led workshops, provided mentorship, and engaged deeply with Techstars Space founders to shape the future of space technology. To the founders, you're contributing to a safer, more secure future in space. Your innovations in areas like satellite communication, navigation, and surveillance contribute to our national security, ensuring that the United States maintains its strategic advantage in space. The advancements we're witnessing here today are not mere steps, but giant leaps in our quest to maintain a safe and secure space environment. These breakthroughs are central in our ongoing mission to protect and defend, not just for today, but for the future of space exploration and utilization. The United States Space Force is proud to stand with Techstars Space and its cohort of visionaries. Let's go forth from here with renewed vigor and a shared commitment to excellence and innovation in the service of our nation's security and the peaceful exploration of space. Thank you.
Hi, my name is Moritz, and I'm the CEO and a co-founder of GatSpace. Before starting this company, our team has been building spacecraft for years. Until one day when everything changed. This was the day we wanted to build a spacecraft capable of moving in space, which required a so-called chemical propulsion system. So we went out to buy one, and we could not believe what we found. The thing is, pretty much all satellite components nowadays are plug and play, which means that they come in neat, user-friendly boxes which you can plug right into your spacecraft. Except for one, as we found out. except for chemical propulsion systems, which come in ridiculously complex sets of hundreds of highly sensitive components, such as thrusters, valves, and tanks. And since every single propulsion system is also different, every system has to be tediously customized, assembled, and tested by experts. Last year, spacecraft operators spent an astronomical $4.4 billion, not on satellites, but on propulsion systems alone. For us, this is absolutely unacceptable. So we went out and built a solution ourselves, which makes moving in space accessible to anyone. We call this product Jetpack. Unlike intricate, finicky legacy systems, the Jetpack is a universally compatible plug-and-play propulsion module. So you simply attach a jetpack to your spacecraft, either before launching to space or when you are already in space. Then, at a mouse click, the jetpack takes you anywhere in space. Per propulsion system, we reduce our customers' cost by a factor of 5 and their integration time by a factor of 10. Within a few years, we'll be saving space companies billions of dollars and millions of man-hours of painstaking, non-recurring engineering every year. Moving in space will be as simple and accessible as attaching a jetpack. But back to Earth. Within only 15 months, having spent less than $1 million, we have not only filed 3 patents, but also built multiple generations of our products and demonstrated that our tech not only works on paper, but also in reality in thousands of hot fire tests. Next year, we will achieve space heritage. And industry-leading companies like Beyond Gravity, the exploration company, and K2 Space are really excited about our fast progress and have signed LOIs worth more than $60 million with us. All of this is only possible because we were already a well-rehearsed team before starting GatSpace. We've been working together for more than half a decade, and in our last project, we pioneered spacecraft development in Austria, supported by companies like Airbus and Red Bull. Today, as a team of 12, we're transforming how spacecraft move in space. Tomorrow, we take our technology to the moon and beyond. Scan the QR code to find out more.
Hello, I'm Patricia from Westwood Aerogel. We all rely on our phones, right? We expect when we charge them, they'll have power, no problem. But that's not always the case. Sometimes it's blazing hot outside and your phone overheats. The battery starts to degrade. Or it's incredibly cold and you may notice your battery drop from 50 to 10%. The charge is unavailable. Now, take these problems and multiply them across all the cells in an electric vehicle. The average range can go as low as 50%, even in popular models. EV designers often employ complicated temperature control systems just to keep the battery stable. When a battery is designed, you start with the basic cell, stack the cells into a module, then stack the module into the final pack for deployment. One way to control temperature is to weave heat pumps into the battery pack, which gets complicated and expensive. Or you can place insulation material between the cells, which will control the flow of heat. Westwood Aerogel does this with aerogel-based thermal insulation, providing full battery pack protection at a fraction of the cost. But what is aerogel? Basically, you can think of a sponge, but imagine that 90% of this material is empty space. And because of that, aerogels are the lightest and most insulating material on Earth, which I personally validated with the blowtorch test. But there's a tension between supply and demand, where many aerogel companies simply can't make enough. The traditional manufacturing method is done by taking this high pressure chamber and making it bigger and bigger and bigger, which is incredibly expensive. Westwood Aerogel is deploying a high throughput process. Where other aerogel companies are spending up to $700 million for new manufacturing plants, we can do the same product output for as low as $20 million. In less than a year, Westwood Aerogel has collected $250,000 in non-dilutive funding from CalSeed, Activate Berkeley, and Cyclotron Road. And we're scaling our manufacturing process through the support of Lawrence Berkeley and Lawrence Livermore National Labs. Once scaled, Aerogel will have irreversible share in a $65 billion global market. And we begin this journey with Techstars Space, targeting batteries on lunar and Martian vehicles. And once our product is validated, we can expand to mobility applications and beyond. Our vision is made possible with a strong core team, including both technical and business expertise, a balance of personalities with the skills to execute. We're taking a hard-to-scale insulation material and creating a mass market opportunity. We would love to talk and share more as we take aerogel from lab to product. Thank you.
Hello, I'm Stacy Jones, founder and CEO of IMMetalX, where we detect and characterize space objects in low Earth orbit. With a record-breaking 40% increase in satellites launched and over $500 billion in space assets at risk of damage or destruction, low Earth orbit is rapidly becoming a hazardous environment. This uptick in activity also creates obscurity that makes it easier for our adversaries to hide and to surveil our military and sensitive operations, creating an existential threat. Adding to the complexity of crowding is that there just isn't full visibility into which objects are hazards, threats, or those that support our daily activity. IMMetalX is addressing this issue with algorithmic software that processes in near real time to answer the questions: what is it? What is it doing? And what is it likely to do next? Our patent-pending Delta is physics-based and optimally detects and classifies objects of varying sizes and types, and even those that have not before been seen. We're advancing our tech to work harmoniously with hundreds of general and specialized sensors in a distributed network offering premier custody management with selectable coverage from a menu of regions. IMMetalX is going beyond conjoining ephemeris data of known assets to applying signal and image processing, convolution, and machine learning to produce specific type and behavior characteristics of objects that cannot or will not tell us who or what they are or their intent. Our scaled system brings actionable insight to military and intelligence agencies to swiftly identify malicious activity, support civil and exploratory space efforts with detection of debris, and assist satellite fleet operators who must make critical decisions to avoid collisions that would damage their assets. Complementing my experience in phased array antenna, beam steering control, command and communication, and distributed processing, IMMetalX brings a high-caliber team of experts to tackle this growing problem, and a go-to-market strategist to ensure that we de-risk the way forward. We've gained traction, now actively supporting the United States Space Force on our 6th contract to super resolve imagery to further improve our ability to recognize, classify, and examine behavior patterns of satellites and debris. With integration automation and operator-in-the-loop technology, IMMetalX is forging the way to a safer and better protected LEO. Let's connect to discuss accelerating our technology that enables next right actions to be taken at the speed of relevance. Thank you.
Hi, I'm Gaurav, CEO and co-founder of Piersite. We recently closed a $7 million seed round to accelerate development of persistent ocean monitoring satellites. Let me start from the beginning. If you've ever seen or played strategy games like Age of Empires, you'd remember that visibility was limited to where you had buildings or units. Everything else was grayed out. It's called the fog of war, a lack of situational awareness. This is the reality for 70% of our planet, the oceans. No organization or country has persistent visibility of their own waters, let alone rest of the oceans. And just like in those games, the fog enables the bad actors to operate covertly without repercussions. For example, 1 in 5 fish is illegally caught, resulting in $24 billion of losses, pushing millions into forced labor and intensifying sea life extinction. It doesn't stop at your plate though. Unsolicited activities like dumping of chemical waste, drug and human trafficking, and terrorist infiltrations are all carried out by dark ships hiding under the fog. inability to monitor and reroute traffic during the 6-day Suez Canal blockage triggered a domino effect, leading to billions in losses. My co-founder Vineet and I have spent a decade at Indian space organizations building the technology required to solve these problems. Our observation was that existing solutions and competitors offered a high-resolution imagery, but only for areas of interest and upon request. At Piersite, we want to make situational awareness a default. To do so, we are building a constellation of backpack-sized satellites equipped with all-weather imaging eyes and ears, SAR and AIS sensors, serving as the primary layer of surveillance across all oceans 24/7. Because we are 1/6 the cost, this enables many more nations and corporates to always be monitoring the oceans proactively, rather than reactively after an incident. We make money from our very first satellite. Our path to 180 million ARR includes revenue diversification across exclusive economic zone monitoring, ship liners, insurance firms, and hedge funds. We are a rapidly growing team of 7. Our first demonstration mission is scheduled to launch on ISRO's POEM platform in June next year, with the subsequent free-flying satellite mission set for end of 2024. These milestones will propel our technology readiness levels to 7 and 9 respectively. And while the oceans are a start, we see a number of terrestrial applications as future opportunities, expanding our TAM. In strategy games, there was a cheat code that would reveal the whole map. Let us provide that cheat code for democratizing round-the-clock maritime surveillance. Thank you.
And now please welcome our special guest, NASA's longest-running administrator, Dan Golden.
We are at the studio of my good friend Bob Weingarten. He is credited with the transformational agent in going from analog to digital artistic photography, and his archives are in the Smithsonian Institution. So space and technology is about transformation, and I couldn't think of a nicer place. I've had a 6-decade career at the cutting edge of technology and space. And at this point in my life, I want to give back. Many people helped me in my career, and I enjoy working with young companies and helping them. And that's why I'm here. My mission, when I had the handshake with President Bush, was to come in and be an agent of change and get private sector investment involved. And if you just take a look at it now, in the last year or two, private investment has been $8.9 billion, and the NASA budget is $23 billion. That's a pretty good number. So there will be a transformation. And as the private sector begins to really build capability, the government wants to back away. The government doesn't need to do these things, and I believe the ultimate direction is going to be, clearly for national security, the government has to be in charge. But for exploration and even national security, there's a major role to be played, and we haven't even seen that transformation take place. And in the end, the American citizens benefit because of the ability to do things commercially. And you do it in scale and volume, and we've seen the time compress. So it's a delicate balance, but it's changing over time. I do a lot of venture capital and private equity due diligence. And too many of the new companies want to copy the brilliance of what Elon Musk did. But if you're going to go vertically integrated, you're building up an overhead and a financial commitment. He has 85% of all the things he does inside. I've seen too many startup companies put too much emphasis on building a vertical integration and not enough of an emphasis on getting their products to market. There's always time. Now remember, Elon had a different situation when he founded SpaceX. He had capital of his own. And as I talk to literally a few hundred of these young people, I try and help them understand, yes, it's fine, but you got to get a product to market, and then you worry about making it vertically integrated. So there's a danger there. A great idea unconnected from a customer is a zero idea. And everyone wants to do business with the national security community, but they need to be highly focused and understand what they have and match it to the marketplace. And this is where I see the biggest problem. And many of these young entrepreneurs have stars in their eyes. I'm in a space business. No, you're not. You're a dreamer. You need to be able to have fundamentals. What's unique about your product? Who is your competition? Who are your customers? Do your customers understand what you're selling? Have you really gone through and got the right level of finance in your seed round? Don't bite off more than you could chew because you get a stomachache and you get sick. Thank you.
Weren't they amazing? We're so proud of how much our founders have achieved in just 13 weeks, and even more excited to see what they'll accomplish next. Hi everyone, my name's Ahmed Mirza, and I'm part of the Accelerator investment team at Techstars. And before closing out this segment, there are a few thank yous in order. First, to our hundreds of mentors, a very heartfelt thank you. As you heard from Matt earlier, we ran 2 different programs at the same time, Techstars Space and Techstars LA. And the impact of this was tremendous. Collectively, in our first month of program, our founders had over 2,000 meetings. And that's quite a lot. To contextualize this further, 2,000 meetings equates to about 28 consecutive days of back-to-back-to-back meetings. So thank you to our mentors for truly living the Give First mantra by showing up and offering your time and expertise to our founders. Next, we have an amazing collection of global partners who stepped in with programming and technical support to help our founders succeed. Thank you to all of our global partners for their ongoing support. And of course, thank you to our team, Joshua, Allison, Caroline, Sherman, Kim, John, Faye, and our program team, Tanisha, Victor, Nick, Andrea, and Erica. Thank you for showing up every day with your energy and enthusiasm. We could not have done these 2 programs without you. And last, but certainly not least, a huge thank you to our founders. We couldn't be more excited about the journey ahead. Thanks so much for tuning in to our virtual demo day.